video, we shall be developing the autocorrection test using e-views as well as interpretation. Autocorrection test, as you know, is very important as an hypothesis that is hidden behind linear regression alongside of normality and homoscedasticity. So it's important to check non-autocorrelation of error term in order to continue linear regression in case the problem of autocorrelation. It is important to fix that issue for having an acceptable econometrics model. So let us start with linear regression estimation. I have for this rural database containing the variable on macroeconomics, and we have general growth, GDP, general gross domestic product in foreign local currency, GDP growth. We have general government final consumption as well as general government investment. We also have gross fixed capital formation, and we use all those variables to estimate a model by using the QUIC. So click on QUIC, estimate equation. Our dependent variable will be gross domestic product in local currency, and independent variable we have a constant intercept. We have general government final consumption in percentage of GDP. We have general government investment, gross fixed capital formation in percentage of GDP, and we keep all these three or only these three independent variables in our model. Then click on OK. And as our linear regression model has been estimated, interpretation is not the purpose of this video. We run the autocorrelation test in order to see whether or not accept or do forward analysis in order to have models that have error terms that are non-autocorrelated. So it's the first time you are watching one of my videos, do not hesitate to subscribe and activate the notification bell in order not to lose my next publication. And it will be interesting if you let me a thumbs up. It will be a pleasure to know that all the effort we are making is helping you increase your knowledge in statistical model for social sciences. So as our model have been estimated, our linear regression model, to run our autocorrelation test, you just need to go in view and then residual diagnostics, and then we'll run the serial correlation LM test. Then click on it, and then we can choose to include a number of lag. We'll keep the by default option, which is 2 lag in our LM test. So we have here Fisher statistics, and probability of Fisher statistics is 0.000. As you know, the null hypothesis in autocorrelation test is that error terms are non-autocorrelated. So as p-value is less than 5%, which is the threshold that is generally chose in social sciences, we reject our null hypothesis, meaning that the error terms are autocorrelated. That is not good information for our model. So we cannot validate our model as far as our error term as autocorrelated. We can, for example, use a logarithm transformation or estimate our model using, for example, generalized least square, and then check our autocorrelation. Then our model will be error term non-autocorrelated. And the purpose of our future video will be to show you how to correct this problem of autocorrelation in the case in which we have error terms that are autocorrelated and didn't yet do so. Do not do subscribe to the YouTube channel and activate the notification bell in order not to lose the next publication. And we'll just say that's it for this video, and rendezvous in the next video. So anytime soon.